Hello, class. We begin activity 4.2 on page 330 from your textbook. The problem they give us is very similar to the last problem we worked on. If you recall, we were standing on top of the Sears Tower, which was 1,450 feet above the ground, and we dropped the baseball from rest. So we essentially just placed our arm over the side of the building and dropped the ball. Well, this new equation, you notice there's a plus 48t. That represents the person throwing the ball up. So the ball actually goes up first and then comes down. In the previous example, the ball just went down. It never went up. Okay. So the first thing we're asked to do is to replicate the graph below. So let's take out our graphing calculator. And we'll go to y equals. I have some junk here, so I'm going to clear this out. And then I'm going to enter the height function, the new height function. Okay, so the new height function looks like this, right? The only difference is we added the 48x to, I guess, represent the upward velocity. Now, when I look at their graph, I'm thinking about a window. So if I press the window key on my calculator, it looks like they go from, say, negative, I don't know, you can call it negative 10 to positive 14 or positive 16, whatever you want to do. But as long as we go past this negative 8 and past positive 12, that would be good for our range on the x-axis. And on the y-axis, it looks like they're counting by 200s, and they go up to maybe 1,700 or so. So I'm going to enter my window now. So here's my window. I went from negative 10 to 15, negative 200 to 1,700. I left my x scale the same for now. Again, to improve the number of tick marks, I can change this y scale, maybe to count by 200s if I wanted to, and I'd have fewer tick marks. But for now, I'll leave everything at 1. I press graph, and I think that looks pretty good. So I would say we've successfully replicated or duplicated the graph that they gave us in the book. Next, we're asked a few questions. I'm going to actually answer these questions out of order. The first question says, what is the axis of symmetry? Well, first we should discuss the axis of symmetry. The axis of symmetry is an imaginary dotted line that splits your parabola in half. I think I have a few examples. You can find this handout in Canvas. Okay, so here are 4 parabolas, and you notice we drew this imaginary dotted line. The imaginary dotted line, really there's an equation that can represent this imaginary dotted line, right? So in this case 1a, the axis of symmetry would happen at x equals negative 2, because my axis of symmetry goes through x equals negative 2. And case 1b, the axis of symmetry, this looks like 2.5, right? If I were to graph x equals 2.5, I'd have an imaginary dotted line, and it splits my parabola in half, right? So notice all of these imaginary dotted lines split your parabola in half, and that is the axis of symmetry, right? It's that the dotted line that splits your parabola in half. And remember, the line's imaginary. We're drawing the dotted line, but it's really an imaginary dotted line. And the equation of this imaginary dotted line is given by this formula. X equals negative b over 2a. Right, so here's the axis of symmetry formula. This you're going to have to memorize. You're going to need this on the test for sure, and it will come in very handy. And just remember, the letter b and the letter a, where's that coming from? If you remember, the quadratic equation has the form of ax squared plus bx plus c. So again, the a is the value that's in front of your x squared term, and the b is the value that's in front of your x term. So you'll just use those to come up with an equation. You'll also notice on the same page, we have this formula for vertex. And notice I have the negative b over 2a. So once I find negative b over 2a, that's my x value. So the x coordinate of my vertex would be negative b over 2a. And then you'll notice f of negative b over 2a for y. Essentially what we're saying is once we find the value for x, we can substitute that value into our equation to find the value for y. Okay, and let's just take another look at a picture. Looking at our four graphs again, if I were to look for the coordinates of the vertex, well, really the vertex is the minimum or the maximum point on your parabola. So if I look at this parabola, the minimum value happens here at -2, -2. Right? So this point down here would be my vertex. The vertex in case 1b looks like it's some value just below +1. Okay. In case 2a, the vertex happens, and this is a maximum value, right? So if the parabola opens up, we have minimum values for the vertex. If the parabola opens down, we have a maximum value for our vertex, right? So our vertex looks like 0, -2, and this vertex for 2b is 3, 3. Okay. Again, this document I'm going to place in Canvas, and you can just print it out. I'll label the document 4.2 handout. And again, just thinking about open up or open down, there's a little bit of text here, right? If a is greater than 0, the parabola opens up. And if you look at these functions, here my a is 2, here my a is 1, so both of these open up. And for the next two parabolas, you see how we have -x², so that's a is less than 0. So I know my parabola is going to open down. The last parabola, we have a equals -3. So we know the parabola is going to open down. So back to our book, we're asked to find the vertex and the axis of symmetry. So we know the formula for the axis of symmetry is x equals -b over 2a. So we can begin there. So I'm going to actually start with the axis of symmetry. And the value we receive here, we're going to use to find the vertex. Okay? So we're going to do that in the next video.